Vance.
I'm surprised you could watch any football on Sunday after Saturday.
Oh, it's a good thing I did not have a heart condition, because after Saturday I would have been like, oh, what in, yeah, that was exciting.
That
was very exciting. And I bet you guys were super sad that you didn't spend that money and get tickets after it being.
Right, yeah. The $300 might have been worth it.
Might have been worth it. Right?
Yeah. But
yeah. I tried to talk Kurt into getting us tickets for the Sugar Bowl, because my cousin from Alabama, I'm like, oh, we should get together with her and meet up there and get.
No. I bet Foots have them.
Yeah, I bet Foots are using them.
Right. I bet they have more than they can use, though, because they had a box in Arlington.
Saw that.
Right?
I saw that. I was a little jealous.
It was a nice day there. I didn't really need the box, but they had one.
All right, complex fractions and order of operations. A complex fraction just means that we have a fraction over the top of another fraction. So we have two fractions within a fraction is a complex fraction. So however you want to write that definition on your vocab paper. The official definition is both the numerator and the denominator contain a fraction. So the easiest way to deal with these is just to remember that fraction bar means division. It's all we're doing is it's another symbol for division, okay? So when we see crazy things like this, we have to think about PEMDAS and how things get worked out. The fraction bar is another way to say that the top of the fraction is separate from the bottom of the fraction. So on this one here, we're just dividing these two fractions. We have a fraction up here. This fraction bar shows division, and then we have a fraction down here. This shows that these two fractions need to be worked out first. Then we divide by the bottom, okay? So anything on top or bottom is just like being in parentheses. We work that out first before we divide.
This isn't the same problem, right?
No,
okay,
these are just three examples.
Okay, because I was thinking, I don't know how they got these numbers. Okay.
Yeah, nope, just three examples. So here is our first one, and it is on the back. On the bottom of your notes, I have given you this review of operations of fractions, how to multiply, how to divide, and how to add and subtract. This first example, 1/4 divided by 2/3. Okay, that's all that complex fraction means. When we divide fractions, what do we have to do? Flip the second fraction and multiply. So when you see this, you have to figure out which one we're flipping. Which one do we flip? Which one do we consider our second fraction here? The 2/3. So you can rewrite it as a division problem. And then rewrite it as a multiplication problem. And then when we multiply fractions, what do? Straight across. So 1 times 3 is, and 4 times 2 is, so we end up with 3/8. I see your funny look, Mason. They just broke this down. They broke that 4 down into 2 2s to see if there was anything they could cancel. That's why they did it like that. Remember when we did that last week and we would break those numbers down to see if there was anything we could cancel out? That's why they did it that way. Don't take a nap. Focus and pay attention. Now, they are going to show you a second way to solve this problem, which is why I put it twice on the back of your notes, okay?
Do they have to do it that way?
Nope.
Okay, it'll just...
You can just multiply it straight across and then reduce when you're done, if that's easier, yeah.
Okay.
So the second way that they do this, I had never seen before in my life. So it is interesting, and you may like it better, or you may be like, no, that's not how I'm doing it. And you can do it just like we just did, okay? So the second way is to find our least common denominator. Oh, come on. Just give it a try. Follow it through once and see if you think it's easier. So our least common denominator between 4 and 3 would be what? 12. So we take that 12 times both of our fractions. Remember, there is that invisible 1 underneath the 12 when we multiply. So 12 times 1 would be 12, and then divide that by 4 gives us 3. And 12 times 2 is over 3, which gives us 8 when we divide. So if I would have been doing this, I would have stuck another step in there that showed 12 over 1 times 1/4 gives me 12 over 4. And all of that is over the top of 12 over 1 times 2/3 gives me 24/3. And then this reduces down to 3 on top of my fraction and 8 on the bottom of my fraction. Okay? You might find that useful, especially when we get to some of these bigger numbers that we're going to be dealing with in our homework, okay? Just remember that's another way to do it. So here is that same chart that I included on the front of your notes, just a reminder of how to multiply fractions, divide fractions, and add and subtract those fractions. We're going to review PEMDAS. PEMDAS says all operations within parentheses, brackets, or other grouping symbols such as fraction bars. So that's just saying that if something is on top or bottom of the fraction, we have to work that out first before we solve. Then we evaluate exponents, multiply and divide, and then finally add and subtract. So these are what the problems on your assignment are going to look like today. 1/2 plus 1/6 times 1/3. When we think about PEMDAS, what do we do first on this? Multiply. So 1/6 times 1/3 gives us 1/18. Now we have to add those two together. What do we have to have in order to add? Common denominators. When we have the numbers 2 and 18, what are our common denominators? What is our common denominator going to be? 18. Can't add them together. We have to find a multiple that they both multiply to. So when I have a common denominator of 18, my 18 stays the same. What does my 1/2 become? 9 over 18. Now I can add those together. When I add my top, I end up with 10. 18 stays the same on the bottom, and then I can reduce that to 5/9. So they walk through the steps of finding that common denominator by using multiples. Oh, just kidding. I thought they did here. That's why I wasn't fast forwarding. Okay, everybody got that one? You wrote down examples so you know what to do, Mason? Okay, good. Don't type it in the computer. That is not the right answer. Here is our next one. 2/3 to the third power minus 2. What does PEMDAS say I have to do first? Parentheses. There's nothing I can work out inside those parentheses, so next is exponents. When I have a whole fraction inside of those parentheses and then my exponent, that means I'm taking that whole fraction times itself 3 times. So 2 times 2 times 2 is 8. And 3 times 3 times 3 is 27. So that gives us 8 27ths. I rewrite my problem, 8 27ths minus 2. How do I subtract this fraction from, or this whole number from my fraction? All right, let's put a 1 under the 2. We have to have a common denominator between 1 and 27. What is my common denominator going to be? 27. How do I find my top number for that fraction? I have to take 2 times 27. What is 2 times 27? So I now have 8 27ths minus 54 27ths. 8 minus 54. What do I have to do to those two values? I have to subtract. So 54 minus 8 gives me what? It gives me 46, and that is a negative because the 54 was bigger. So I end up with a negative 46 27ths. They don't make you reduce that into a mixed number. Isn't that nice of them? If you wanted to reduce that into a mixed number, how would you do that? Divide. 46 divided by 27. Our next example has a negative 1/2 plus 1/5. And then it has another set of parentheses, 7/8 plus 1/8. What do I have to do first? The first set of parentheses. So I am adding these two fractions. In order to add these two fractions, what do I have to have? A common denominator. What is a common denominator between 2 and 5? So I end up with a negative 5/10 plus 2/10, and then I have the quantity of 7/8 plus 1/8. What is negative 5/10 plus 2/10? A negative 3/10. And I'm going to go ahead and stick parentheses around that when I write it down, because I'm not ready to get rid of those parentheses yet. What is 7/8 plus 1/8? 1, or 8/8. Is there anything between my two sets of parentheses to tell me what's going on here? There's no addition sign, there's no subtraction sign, they're just two sets of parentheses next to each other. So what does that mean I'm doing? Multiplying these two numbers. So negative 3/10 times 8/8. What does 8/8 reduce down to? 1. What is a negative 3/10 times 1?
I don't know.
Anything times 1 is just that number. So even though it looks difficult, if you work it out step by step, it's really not that hard.
Listen to you, Mason.
There are a lot of steps. That's why I only gave you 11 problems on your homework today. For our last example, it says 2x squared plus 3y when x is 1/3 and y is 4/5. So the first thing we have to do is substitute these values in for our numbers. So you should have something that looks like 2 parentheses 1/3 squared plus 3 and a negative 4/5. What am I going to do first in this problem? The exponent. What am I taking times itself? What am I squaring? Just the 1/3. Do not include that 2 in there. Only the 1/3 is getting squared. What is 1/3 squared? 1/9. Now I have these numbers right outside the parentheses. What am I doing with them? Multiplying them times what is inside the parentheses. So 2 times 1/9 gives me, remember there is that 1 underneath that 2. Multiply straight across. So 2/9, 2/9. Same thing with that 3. There is that invisible 1 underneath the 3. So when I multiply that, I end up with -12/5. Now I have to add these two fractions together or subtract these fractions, depending on if you're adding a negative or just subtracting. What do I have to add or subtract? Common denominator. What's the common denominator between 9 and 5? 45. So I have to take 2/9 times 5 over 5. Except I wrote the wrong number. Ooh, what's 12 times 9?
108.
Nice job. So I have 10 over 45 plus a negative or minus 108/45. What is 108 minus 10? -98 over 45. And they're not going to make you reduce that. They're going to call that your answer. This is what you are doing on your homework today. Cannot just Google the answers. Write out your work. Show me your work. Even though it's online, you're going to need a notebook paper. Okay? There are 11 problems on your homework. Any questions before you get started?
I'm all right if I do homework in this class.
No. Not.
That is a good question, Valeria. I am not sure